Hi, everybody, and welcome. Before I start, a big thank you to Monica, who planned this very well. And one of the results you can see here on my first slide, which I shamelessly stole from her. So our workshop is dealing with R, and I try to give you a workflow-oriented approach. So I will show you one way you can handle R. There are probably other ways. I believe my way is a good way, but I don't want to claim that there are not other good ways you can go. So let's start. Let's look at other softwares. Why should you use R? And if you look at other softwares, there's Excel. And I would suggest not to use Excel for statistic analysis. It's a spreadsheet program, but it's way too basic for statistical analysis. And most importantly, you will see that later on, whatever you do in Excel, you have no track record of what you did. If you made a mistake, you don't know where, and you cannot correct it easily. Another candidate, what is widely used, especially by political science, is SPSS. It is very good in processing surveys. However, it has a limited functionality and it is not free. Then there are programs like SAS and Stata. They have a great functionality. They are not always state of the art. The reason is if something very new comes out, it has to go through the corporate ladder in these companies. That takes time. It might not fit in their marketing schema, so it may take longer until you see the results. But the main disadvantage is these programs are both relatively expensive. If you look at data science, Python and R are the most used programs. And Python is used together with Jupyter Notebooks. That's basically a graphics user interface for Python. And R is used with RStudio, and you will see that. Both programs are very strong. They're both free. And most importantly, they have a great support community. So which one is better? Very difficult to say. Besides, you can execute R code in Python and you can execute Python code in R. What to expect today? I will show you how to install and set up R, and I will show you a few tricks with that. Then, which is very important in data science is, and in econometrics as well, you have to pre-process your data. You want to clean your data. You want to add new variables, which is called data engineering. And I will show that in part 2 and in part 3. Part 2 is a little bit more basic, and part 3 is a little bit more advanced. So let's start. I will make these slides available. And by the way, they are created entirely in RStudio. So I will save them as PowerPoints and mail them out to you. And you find a link here where you can download R. Here you can download RStudio, and when you install the programs, it's very important that you install R first, and then you install RStudio on top of it. R itself is very basic. However, there are many modules you can add to give it extra functionality, depending on what you're working on. And one of these modules is the tidyverse. And the tidyverse is almost like a must in R. It makes your life so much easier. So you want to install that for sure. And here where my mouse is, there's a little link for a 1-minute video that I made a while ago. You can import data from Excel into R. And this video shows how it is done, and I will show it to you. And here's a link to a data camp course. It's free. Unfortunately, not all courses are free on data camp, but that one is. It's a great introduction into R if you want to go a little bit further. And here's an advertisement from myself. Our department offers a winter course in R, data engineering and analysis with R. The course is mostly online. However, we will meet about 6 to 7 times during the course. And we will do hands-on R programming, hands-on R data cleaning. No advanced or no statistical knowledge is required and no econometrics knowledge is required, because we will focus on the data in this course. And last, for sure not but least, there is a great offering from graduate studies, and it's nothing that will go on forever. It's based on a grant. Graduate studies offers free quantitative tutoring. And if you're a graduate student, the only thing what you have to do is drop me an email. We will find a day and I can give you individual tutoring, if it is about R or about other quantitative issues. So let's go to R, the setup, and how to import data. Here is RStudio, how it will open to you after you installed it. Remember, you want to open RStudio and not R itself. It has 4 windows and you currently only see 3. There's one window here that shows the value of your variables, and there's currently nothing in here. Here's one window that has your files, and there is one window that has the intelligence of R. And let me show you how it really starts. You go here, you open RStudio. Here it is, and you can see here the files menu shows some excerpt of a labyrinth of my computer. There's Camtasia, there's ArcGIS. They're certainly not the files I want to work with, but we come to that later. What I want you to do is, and that will save you a lot of trouble, when you first use R, go to the Tools menu, go to Global Options, and then it looks like here, I purposely reset it, restore R data in workspace at startup. And trust me, you don't want to do that. It restores the values of your variable. It just sounds good, but it creates a lot of trouble. And you just say never and save it. So now let's look at this window here, which is called the console window. This is where the intelligence of R is. Let's see how intelligent R is. 2 + 2. And now I enter, push the enter button, and you say it's 4. You can also use variables. A = 3. And nothing happens here because the result went into the variable 3. So the variable A holds the value 3. See a variable as in R as a container. This container can hold numbers, but a variable can also hold a whole table. It can also hold a whole model specification or way more complicated things. So let's define another variable. B = 5. And now I can say A + B, and I type return. And you see here in the console window, the result is 8. And many times I want to store my result. So I create a variable and I can call it whatever I want. Don't add blanks or special characters. I call a result. And sometimes I add my initials to mark it as, hello, this is a variable I defined, and it's not a variable that is a standardized R variable. Result CL is A times B. And if I hit return, you can see here it's 15, but it is not spit out to the console. If I want to output it in the console, I can use a print command. And before I do that, we talked about variables. They hold values. Then R, like most other statistics softwares, has functions or commands or whatever you want to call it. And how these functions look like, they have a name, in this case, print. They have an open parenthesis and they have a closed parenthesis. And inside the parentheses, we have parameters. That's information we push to the function. In that easy case here is, what do I want to print? I want to print results CL. Here's a hint. When you type a variable, type it slowly, RES, you see here, and after 3 letters, it shows it. I know you can type way faster than using these procedures, and I can do, but if you use this procedure, you avoid spelling errors. You will see I don't always follow my own advice, and you will see I do a lot of spelling errors. So print results CL, and here we are, 15. Well, one thing is my variables are not saved. So if I close R here, everything is gone. So how do I save my work? Well, let's try. What I do is I work not in the console. I work what is called an R script. I open one here, file, new file, and it's called R script, which is a really big name for a file that is simply a text file. These R scripts have text in it, so they keep track of your work, but just in terms of text. And I reset my session here. And R has forgotten everything. I can clean up here also. And look, A equals 3. I do the same thing. And what I could do, because this is just a text file, I could copy it and bring it down to the console window and execute. A equals 3, works. Painful, but it works. So I write now B equals 5, and I do exactly the same thing. Click here on run. The text is copied down here, and it is executed. See? And now if I type results equals A to the power, and I don't have to be necessary at the end of the line. I can be anywhere inside the line, but I don't want to be like this. Nothing marked, but somewhere inside the line is good enough. I run it, and here it is. So I would save my R script file, just the text, and let's delete everything. So there's nothing left over. But now I have the advantage, in a few clicks, either click run or control enter, and it's control enter in that case. Run, 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 and I'm back where I was. Another thing what you want to do is you always want to work with a project. How do you do that? Well, first you create on your computer, you create a folder where you put all your data in, where you save your scripts and so on and so on. You can do that with File Explorer or any other file viewing system. After you do that, you create a project in that folder. Then R would always know which is the folder you work with. And put it somewhere on your hard drive. Don't put it on your desktop. So let's see, I do this here, File, and I create a new project. New project. I use an existing directory. I find the directory where all my files are in. I say open. And then I say create project. I did that already, so I don't want to do it again. So in this case, I say cancel here. And the advantage, if you start an R session like I did here, you just go to File, Recent Projects, And you see here is my project. And now you see I'm not somewhere on my computer. I'm in the folder where I have all the files, in this case, for this presentation. So I have this one here that I will need later on. That's my R script. I don't want to type everything. And my session is totally reset. So I told you already about the tidyverse and other packages. These are the modules. What you have to do is, before you can use a module or a package, you have to install it. So I say your tools, install packages, and you have to do this only once. And then it says here, tidyverse, and I start typing tidyverse. And here it's auto-completed. And I would say install, leave install dependencies checked. And if you are asked if you want to install the binaries or the source code, always choose the binaries. The source code might make sometimes trouble. So I don't do that because I have installed it already. So I click cancel here. But although I have the tidyverse on my hard drive, it's just on the hard drive. It is not loaded into R. In order to do that, I have to use the command library. Again, same thing. Library is the command name, open parenthesis, close parenthesis, and then in the middle, I say what to operate on. So I execute this here. I also load tidymodels. You would have to install that first. And another library that will help me to read Excel files. So how do I read an Excel file? I have one here. And I can click on it. And it says view file or import dataset. I choose view file because what it does here, it will open Excel. And I want to show you the Excel file before I import it. What I do is I download data and save them in Excel. And here's the download. It doesn't look very perfect because it has empty lines here, and my variable names should be in the first line. Some of the variable names are not very informative. Some of the variables I don't even want to. So what I did is, and what I always do, I take the original data and I do not touch them because I want to know what did my data look like before I worked with them on Excel, because Excel leaves no track. Move or copy, create a copy, and I click OK, and I have an exact copy of my data. I called this one data clean, and these ones are already cleaned. And you see, many of the variables of the columns, I deleted them. I don't need them. I also renamed my variables. I like to rename them here. You can see it. It's called camelback. So you don't want to use blanks or special characters in your variables. You could use the underline. I think it's a little bit easier to read if you just put the words together. But whenever a new word starts, you start with a capital letter. I want to get your attention to these holes in my data. The original data set was actually clean. I just deleted that here on purpose. So you see, some of the records don't have a sex variable. Here is one missing. Tenure is missing for this record. And education is missing for this record. I just want to get your attention to it. We will look at this later. So now the question is, how do you import your data into R? And the easiest way to do is you import them from an Excel file. Here's a command, but it looks a little cryptic. So I delete it and I show you how it can be done easier. So I find my data again. Here they are. I click on them. And now I don't say view data because that would open Excel. I say import data set. This looks pretty bad. Why does it look so bad? Well, because this sheet in my workbook is the original data. And there, even the variable names were not even in the first row. So I don't want to use that one. Never use default. Always click and use your cleaned data. And that looks already way better. You should check if the numbers double stands for numeric. You see that here, that's okay. Non-white is a character, NO or YES. R would not know that it means yes or no. For R, it's just a collection of characters. Same with sex, married, and number of dependents. So everything looks good here. And I could just say import data, but then I would have to do that every time. What I can do instead, here's a command, you see it? It reads the data and assigns it to the variable wage data modified argtalk. Well, I take this one here and copy it, and I cancel the import. And now I paste it here, and now my data are assigned into the variable data CL. I execute the line with Control Enter, and you can see here, here's my table. This table in R is not called table, it's called a data frame, just another word for table, or sometimes a tibble, which is kind of confusing. But what you can see here, the variables are in the columns, and the observations are in the row. And you can also see here the NAs, these were the holes in our data set. And all is stored in one variable. And I called this variable data CL. Now I want to do a calculation with this data. So I want to calculate the mean wage. And these data are from 1976. You will be surprised how low the wage is. Well, this points here to the table. But what I need also be more specific. I need the column of the table, and I can get that when I print the $sign. I don't even have to type it. Here's wage. It calculates the mean or the average of the wage column or the wage variable in the table data CL. Run it. And it doesn't go to the console because the result is pushed into a variable, but you can see the variable here, mean wage 5.89, pretty low hourly wage. Okay, let's start with part 2, and I go to my presentation here. So what are we doing in step 2 or in part 2? We have imported the data, we set up R. Now we want to process our data. And the tidyverse has a lot of commands to process data, very, very powerful commands. And I want to introduce only what I believe the 3 most important ones. There is one command where you can say which variables you want to select. Often a table is so big, you want to create a new table that has only a few of your variables. You select variables with the select command, open parenthesis, close parenthesis, and the first parameter always is the data you work on. And then you add simply the variables you want, 1, 2, 3, or whatever you like. Sometimes you want to filter your observations. You don't want all the observations. Let's say I want to do research only on women. Then I want to use the filter command. And how does it work? Again, first the data that I want to filter, and then the criteria. Sex should be equal to female. And then the last one, And one of the most important ones is how to calculate new variables in an Excel-like way. And unfortunately, this variable is not called calculate, it's called mutate. Same procedure. The mutate command, the data you want to operate on, you name a new variable that you want to create in your data set, in your data frame, and the formula on how to create it. And last but not least, you can chain all these commands together with what is called the pipe operator. And I will show that to you in a minute. But first, we will focus on these three variables. So we go back to R. And here's my goal. I want a new table, a new data frame that has only the variable sex and the variable wage. I also want only women in that data frame. And lastly, I want to convert my wages from 1976 to the purchasing power of 2021. That is called data engineering. It's a very simple data engineering task, but I create a new meaningful variable. That's basically the essence of data engineering. So how do I do that? So here's my new data set, and I want only wage and sex in that data set. Okay, so the data I'm using is data CL. And now come the variables. I want sex in the data frame, and I want wage. And I could execute this, but I want that the wage variable gets a different name. It should be actually called wage 76. So I know this is a wage from 1976. I execute this here. And if I go to my environment, here is a variable. And here you see the sex variable and wage 76. Okay, now I want to filter. So what do I want to filter? Well, the data set, the data frame I just created, data always is first. And now you would expect something like that. Sex equals female, and make sure you have to spell it right. So you want to check if it is spelled capitalized or lowercase or starts with a capital letter or whatever. This one is spelled correctly, but I have to correct one more thing here. Instead of one equation sign, I need two equation signs. That is, I do not assign female to the sex variable. I'm saying the sex variable is supposed to be female, and that is expressed in these double equation signs, and you will find them everywhere in SQL, in Stata, and SAS. That's a common source of error, but it is a relatively easy to catch. So I execute it with Control Enter, and I get a new data frame. And you see already it's small, there's only 251 records. And indeed, it has only women in that data set. Okay. So now comes the last step. I want to create a new variable, wage 21. And if I multiply wages, I got the factor 3.8. I calculated it from FRED data, Federal Reserve of St. Louis. So if you multiply wages from 76 with 3.8, they are similar to wages of 2021. So what do I have to do? I have to create a new variable, and I call that wage 21. I basically copy this thing in here. But the first argument, again, has to be my data frame, and would be the one that I calculated here because I only want women in this data frame. Control V. Oops, that didn't work, sorry. Here is a data frame I like to use. I copy it in here. And I execute the command. And I finally have what I want. See, only woman, wages from 1976, and the one that I calculated. There's only one thing here. I have used a lot of intermediate data frames here. That makes it kind of difficult to read my code, and it wastes a little bit of resources. There's a better way. I can pipe my commands together. How do I do that? The piping operator, what it does, see it like a funnel that goes from left to right. Whatever is here gets into the funnel and gets then pushed into the next command as a first argument, as a data argument. That's why I don't need a data argument. Whatever the result is here gets pushed into the next command as a first argument. And then the same here. So let's start with select. I copy my code. And I don't need the data parameter because it comes here from the left side. I take my filter result, and I don't need the data command. I just need this one here. I push it here. And then last, I need my calculation result, my mutate. And again, I don't need the data result because whatever comes out here as a result gets pushed into the mutate command, and then it's operated on it. In this case, a new variable wage 21 is calculated. Well, I also told you it's easier to read. Right now, it really doesn't look like it's easier to read, but R allows you to make line breaks as long as you make them correct. And that means you have to make the line break behind the pipe operator here. And then if you indent a little bit, then it's very easy to read. Take the data set data CL, pick only the variables, select only the variables sex and wage, filter by female, and calculate a new variable. And now I can execute this line at once. And let's remove the other ones here to clean up. So nothing is there anymore. And I execute this code here. And here we go. I can do the same thing for male. And in R, it always helps to copy and paste. Because the only thing what I have to change here is I want to filter for male. And here we go. Now I have two data sets. One is only for male and one is only for female. And it's an accident that they're equally big. And I could calculate the mean wage for male and the mean wage for female. And I would see that they're different. The command is there, but I don't want to use that command. I use instead a Ttest. That tells me so much more. So what does a Ttest requires? It requires two variables from the same or from different data frames. So these are the female wages, all the female wages. These are all the male wages. So now I run my Ttest here. And we see females have a wage of 17, male of 26. Well, that's a pretty big difference, but it could have been just happened by accident. And the answer is, well, most likely not. Chances that such a big difference comes just by accident, chances are the probability related to that is pretty much 0. So I can also run a regression on that. The regression command, same thing, always the same thing. Have the command here, open parenthesis, close command, and then push some parameters. The first one is the formula here. And that is read a little bit different. On the left side of the tilde, we have the dependent variable, the outcome variable, the one we want to predict. On the right side, we have the predictors. And they can't be separated by commas because parameters are separated by commas. They are separated by plus signs. So that's a formula. And then, of course, I have to say which are the data CL. And nothing happens here. Nothing happens here because the results, and there are a lot of results, are saved in the variable model LM. And instead of chasing, if you would click on this model LM, you get a pretty nasty list of information. Instead, you use a command that's called summary. You put the model variable in it, and summary gets everything out of it, what most people would be interested. And you can see here that we have the coefficients here. We have the t-value and standard errors, and you can see all our variables are significant. You might see, hey, wait a moment. The variable was called sex and not sex male. Well, the LM command is smart enough to recognize, hey, that's a character variable. But it has only male and female. So I code male as 1. That's why it says sex male as 1. And this way, we have generated a dummy variable internally, which is not very clean, but at least it works. So let's clean up here. Now I want to show you something that is called tidymodels. I want to put that into perspective. If you understand how far we got here, that will get you a wide range. If you understand tidymodels, and especially the recipes, you can do very sophisticated things with very, very simple procedures, and your code will be easily readable. And I want to show that to you. And here's the idea of recipes. We define a recipe. That means recipe stands for how do we want to pre-process our data, how we want to process our data. And we add different steps to the recipe, like a recipe in the cookbook. Then we put the recipe itself, which is just instructions, nothing has happened yet, and the data together. We apply the recipe to the data, and the command is called bake, and we get the pre-processed data. The advantage is not only that it is easily to do, is now if you want to apply the same recipe to different data, you just put the recipe that you already have together with new data, apply it, and you get new pre-processed data. Let's take a look. So what I do here, and I don't want to comment a lot on it, in machine learning, and actually should have been done in linear regression too, but it's not very common. We want to make sure that our model does not approximate. We want to make sure that our model actually can forecast well. So what we do is we pick randomly observations, here 15% of the observations, and assign them to a data set that we call test. And all the other ones are assigned to data set train. And we use only the training data set to run our model. So I can do this with these commands here. And now comes the recipe from tidymodels. So I need data. These data are pushed to the command recipe. You can see that here. And that's why this recipe has no data argument here. It also has a formula. And sometimes a recipe needs to know what is the dependent variables, what are the independent variables, but also later on when we process the recipe, we can use the formula. So I provide the formula here. Wage is the dependent variable, education, experience, tenure, and sex. And that also clarifies which of the variables I want to select, these 5 ones. And now I use steps here. And if you want to see all the steps available, you can look at that link here. Remember, education and tenure had empty records. We could simply throw out these observations. But that's a waste because everything else is intact in these observations. So why not fill something in? And filling something into data is called imputation. Think just of the opposite of amputation. You add something new. So it's called mean impute. So what we do is we take the variable education and tenure, and wherever it has non-available data, it puts the mean of education or the mean of tenure in there. That's a good procedure to save some of our observations. Well, we can't really do that with our sex variable because we had male and female, and even if it's 0 and 1, if you don't have data, you don't want to put 0.5 or 0.37 or whatever in there. What we want to do here is, if we have an observation that doesn't have a sex variable, we take the majority of the sex, female or male, and put it in there. That is called mode impute. And you see already all these steps start with the word step, underline, and then comes the procedure. So now our variables are complete. They would be complete if you execute the recipe. Now we want to change the sex variable into a dummy variable. And instead of writing sex, it would just work fine. I say all nominals. So if there would be more than one, it would be processed on all of them. Here it doesn't make a lot of sense because we have only one. And as a good practice, always end a recipe, almost always end it with a prep command. That means that all these things are really calculated. I execute my recipe here. And now I can see here, if I bake it, that's my bake command, and the first argument is a recipe. So this is just a recipe. If I have a cooking book and there's a recipe for cake in that cooking book, it doesn't mean the cake is in the cooking book, just the instructions. Same thing, these are just the instructions. But the moment I run the bake program, it executes these instructions here on my data set, on my training data. Okay, so I run it, I save the result in data temp. You look at it, you can see here data temp. There are no holes anymore, and our sex variable has now a 1 wherever it's male and a 0 wherever it's female, so it was successful. Our training data set had 448 records, so does our temp data set. I want to do the same thing on the test data set. The only thing I have to do is change the input data set here and execute it. Look at data temp here. This is the testing data set, and it's way smaller. It's only 78 records, and it doesn't have holes either, and the sex variable is nicely formatted. We have a little bit time to take a look at the tidymodels, and that is, I admit, a little bit advanced. I just want you to keep it in your head. If you do a little bit more advanced things, you know you can simplify it a lot by using tidymodels. So a workflow is this here. So same thing than before. I define a recipe, I push the data to it, but now I define in addition a model So workflow has a model that I want to fit, that I want to optimize. It has a recipe and it has the data. Then I can execute the model, predict with it, and I get the predicted data. I can summarize these data, for example, to calculate R square or the mean average estimation error. And I can also always use new data to predict. And I will not be able to show all of this to you, but I will be able to show some of this to you. So the recipe is already defined here. Recipe CL, I called it. So I get rid of data temp. And I create my model. And I save it in a variable. How do I create my model? It has 3 steps here. They are true for every model. So it's a linear regression. So the command is called linear regression. And here's a list of all the models you can use, from simple linear regression to most advanced machine learning procedures. Set engine is, where do we find this model? It is LM. It's in LM package. And then the only thing you have to do is you have to say, is this a regression or classification? So this one will be either regression or classification. That's it. Again, nothing is done here. Only what I want from my model is saved in this variable. Now I create my workflow. It starts with the workflow command. I add my recipe, the one that I already defined. I add a model LM, and I run it. And now I can type summary. And here I get the same summary with slightly different results because I use the training data. And without going in detail, I can use this model, this fitted model, predict on the data, on the training data, and summarize everything into metrics. So I do that here for the training data set and for the test data set. And if I look here, here are the results for the test data set. Look, here's my R square. Here is my mean average error. And I can see the same for the test data set. So I'm done with this model. The advantage is, even if you do it like that, you see how simple this thing is. Your recipe, that was simple enough. And then these few steps, and it's easy what you're doing here. But the bigger advantage is, and I bravely will use copy and paste again. I copy and paste this code, but not the recipe. And I want to run now a machine learning model. And this model is a totally different model. And it is not in the tidymodels. It is made by somebody else, has different parameters and everything. Needs to be called in a different way. But tidymodels streamlines everything for us and kind of translate it. So I copy this here. And I need definitely a new model, and I want to save it in a different variable. So I call this variable RF. And it's not called linear regression, obviously. It's called random forest. And I don't go into detail. It's a machine learning model. Here it is, rand forest from the parsnip package. Set engine. In the documentation, you will find that the engine is called Ranger. And it's still a regression. That's it. I have created a machine learning model. I have not run that model. Now here's my workflow. The one I created before that has everything in it. Well, it has a recipe in it. I don't need this here. And I want to change the workflow. So I take the old workflow. And I don't add another model. I update the model. Everything else should stay in there. I just say update model. With other words, replace the old model, add the new one. And what I want to put in there is RF, random forest, and I fit it with the same data, with my training data. So I execute that and took about 1.5 seconds. I ran my machine learning model. The summary is a little bit more difficult to interpret, but what I can do here, I can calculate my metrics, and obviously I want to give them a new name, RF. And that's the only thing I have to change because it uses a workflow, but that one is updated. It predicts and creates my metrics for the training data set. And I do that same thing for the test data set. And now let's look at the results. I told you already we should really not look at the training data because they just show approximation. We should look at the test data. These are the data the model has never seen. So how is our linear regression doing? Based on the test data, it has an R-square of 0.29 and an average error of 1.73. If I now look at the metrics from the random forest, you can see the R-square is bigger now, 0.34 instead of 0.29, and the average error is actually smaller. So we could improve our prediction results with using random forest instead of linear regression, which doesn't matter here too much. The data set is relatively small. I just want to show you the procedure. I can also show you why you don't want to use the training data set, because if you look at the training data, you can see the linear model has actually a R-square of 0.31. And now look at the random forest. It has 72%. That doesn't mean the quality is 0.72. It just means it approximates the training data so well. The real standard to compare are actually the training data. Thank you very much for your attention.